This is section 11.4, number 9 in your e-text, Algebra 2, Martin Gay, 2016 edition. In this case, we must graph a rational function with a constant in the numerator. The first step is to determine the horizontal asymptote. To do so, we need to compare the degree of the numerator to that of the denominator. There's an invisible x to the 0th power, since anything to the 0th power is 1. So the horizontal asymptote is y equals 0. Since the degree of the numerator is less than the denominator, 0 less than 2. The vertical asymptote occurs where the function is undefined. The function is undefined when the denominator equals 0. Now, you could factor x squared minus 4 using difference of 2 squares, but you could also just add 4 to both sides and then square root. Square root of 4 gives plus or minus 2. Part B would be the intercepts. The x-intercept occurs when y is equal to 0. So we set y equal to 0, numerator over denominator. Now you don't need to show this much work, but just for notes purposes. To solve for x, it can't be in the denominator. So I multiply both sides by x squared minus 4. Now x squared minus 4, these factors cancel. The left side, anything times 0 equals 0. We reach a false statement or a contradiction, similar to the example we did in class. This suggests that the x-intercepts are none exist. So real quickly, let's just reference this and compare it to the example we did in class. Likewise, in the class example, we had 0 equals negative 2 over x squared minus 1. The denominator cancels. We get 0 equals negative 2, a false statement. Next, we do the y-intercept. Set x equal to 0. So we get y equals negative 1 over x squared minus 4. Negatives cancel. We get 1 over 4. Last step, now we just plot the graph. But we need some additional points. I place all my x values that I found on the number line. These x values were the vertical asymptotes. So I want to pick a negative 3, something to the left of negative 2, a number between negative 2 and 2, and a number greater than 2. F of negative 3 gives negative 1 over negative 3 squared minus 4. That's -1/5, or -0.2. Next, f of 0. Well, this is to save time. Notice how we could have picked a number other than 0, such as 1, but we already found f of 0. That was the y-intercept. This is just 1/4, calculated previously. Next, f of 3. Well, that's going to be the same calculation as when we did f of -3. So this gives -1/5. Next, we plot these on our graph. X-axis, y-axis. I'll plot 3 lines. Might be a little messy because I'm using Zoom, but we'll make do. Plot the vertical asymptotes. These are at -2 and 2. Horizontal asymptote was the x-axis, y equals 0. Perfect. Y-intercept was 0, 1/4. Then we had -3 on the x, -0.2 on the y, 3 on the x, -0.2 on the y. Bend towards the asymptotes. Oops, try to pass through those points. Notice how my parabola faces up because I don't want to cross through my horizontal asymptote. So I bend away from the asymptote. Finally, you can check your work using Desmos. Here I typed in the original problem, and I could check my y-intercept. And I could check the value of -3. When I'm at -3 on the x, I'm at -0.2 on the y. Perfect. So that's how you can plot your graph and check your work.